Hello everyone. Yesterday we have completed chapter 2, the polynomials. Some extra questions we have done. Now we are going to start chapter 3, pair of linear equations in two variables. This chapter is also named as simultaneous equation in two variables. Simultaneous means together. Means we have two equations together. In class 9th, you have been taught about linear equation in two variables and you had plotted the graph there. You have got some solution of the equations. Here we are given two equations simultaneously. Like I am writing general equation. Suppose we have an equation a1x plus b1y plus c1 is equal to 0. Equation number 1. a2x plus b2y plus c2 is equal to 0. Equation number 2. This is of the form ax plus by plus c is equal to 0. You have seen in class 9th. Now in class 10th we have pair of equations. There in class 9th you have plotted the graph of the equation. You have got some solutions of every equations. Now here we have two equations, means we have to find the combined solution of two equations. Combined solution of two equations. You have been taught that a single equation in two variables will give you infinite number of solutions. Infinite number of solutions, and you had plotted the graph of the equation and you have got a straight line. Because it is linear equation, so you will get a straight line. So for a single equation you will have a straight line. Now if you have two equations together and you plot the graph of the equations, you will have two lines, and two lines on the same graph when plotted. Three conditions are there. What conditions? Means how the two lines are together with on the plane. Means the lines interact with each other or not. So three situations are: number one, the lines may be intersecting each other, or the line may not be intersecting each other, or the line overlapping each other. Three situations. Out of other than these three situations, no other situation you can find. Means if you plot two lines on a plane surface, either the line will intersect each other, or the line will not intersect each other, or the lines will overlap. When lines intersect each other, the property of straight lines, two straight lines if intersect each other, there must be a common point of intersection, that is only one point of intersection. If the lines are not intersecting each other, it means the lines are parallel, and if the lines are overlapping each other, means the two lines together represent a single line. Now regarding solution of the equation, two methods are to obtain this solution. One is geometrically and other is algebraically, because algebra is treated with geometry. So first of all, let's see how many kinds of solutions are there according to the rule. Solution of the equations will be due to interaction of the lines. due to interaction of the lines. So let's see, if the two lines intersect each other, suppose this is x-axis and this one is y-axis, and one line goes in this way and other line goes this way, so we have a common point here. Common point means this point P, suppose, is the common in two lines. Means whatever the coordinates, suppose this is x comma y, is the solution of the equations. And you know that there must be only one common point. Means we have unique solution. When two lines intersect each other, we have a unique solution. Means only one value of x and only one value of y. By drawing perpendiculars on the axis, we can get the values of x and y. If two lines intersect each other, we have unique solution. And if the lines are not intersecting each other, means lines are never meeting each other, so situation may be like this. Yes, I am representing by graph. This is x-axis and this one is y-axis. Suppose this line is going this way, another line is going this way, and both the lines are parallel. Means they are not intersecting. Means there is no interaction between lines. Means lines are not meeting anywhere. It means we have no solution. I told solution of the equations is due to the interaction of the lines. If these lines are interacting in one place, means we have only one solution, that is unique solution. These two lines are parallel, means meeting nowhere, means there is no interaction between lines. It means the equations will have no solution. One more condition, suppose this one is x-axis and this one is y-axis, and a line goes this way and another line is overlapping this line. Means both the lines are representing a single line. Means every point lying on this common line is the solution of the equation. Means we have a single line, and you have been taught in class 9, for a single line we have infinite number of solution or infinitely many solution. So here we have unique solution. Unique solution when lines intersect each other. Here we have no solution. No solution. And here we have many solution. Many solution. Means we have three types of solution for the pair of simultaneous equation. If two equations are given in this form, so we can have three types of solution. Either the equations will have unique solution, or they will have no solution, or they will have infinitely many solution. So these are three criteria of getting solution due to geometry, means geometrically proven. Now we have another idea, which is algebraic method. Algebraic method to check the number of solutions. See, if two lines intersecting each other, before proceeding this, I would like to tell you one thing. Can you tell me what is the role of coefficients of x and y in the equation? Very important thing to know. What is the role of coefficients of x and y and the constant term in the given equation? Can you answer? Let me tell you. The role of coefficients of x and y of the equations is to represent the direction of the line. Means a and b, that is coefficient of x and y, decide in which direction is line is going to pass. And c is the perpendicular distance of the line from the origin. Let me tell you one example. See, suppose we have an equation x plus y is equal to 5. X plus y is equal to 5. Here coefficient of x is 1, coefficient of y is 1 and constant term is c. Let's see what is the direction of the line. If you plot the graph, I am taking 3 points. Suppose I am taking 3 points here, making a table. You have drawn in class 9 x and y axis. Put x is equal to 0. If you take x is equal to 0, then what is the value of y? 5. If you take x is equal to 1, then what is the value of y? That is 4. If you take x is equal to 2, then what is the value of y? 3. Let's plot the graph, rough diagram. See, I am plotting it. The first point is 0, 5. X is equal to 0, y is equal to 5. Suppose this point 0, 5. Another line 1, 4. This is suppose 1 and this one is 4. I am taking this. 1, 4. 2, 3. X is equal to 2, y is equal to 3. Suppose this point. So when you will join this, the direction of the line is in this direction. Line is passing in this direction. Means when coefficients of x and y were 1 each. And this distance is 5 unit from the origin. That is c. Suppose I am changing the equation. I am taking x minus y is equal to 5. Here coefficients are changed. Coefficients are changed. I am removing this line. So again plot this graph. What we have, let's see. X and y, at least 3 values. If you put x, y is equal to 0. If you put y is equal to 0, then what we have, x is equal to 5. If you put y is equal to minus 1, y is equal to minus 1, then what we have, x is equal to 4. Minus into minus plus 1, this goes into right, becomes 4. If you put y is equal to minus 2, y is equal to minus 2, then what we have, x is equal to 3. Let's plot this graph. 5, 0, x is equal to 5, y is equal to 0. Let this point is, we have 1, 2, 3, 4, 5. This point. Suppose this is 5, 0. 4 comma minus 1. This is 4. Suppose and minus 1. This point. 4 comma minus 1. Another one is 3 comma minus 2. 3 comma minus 2. This is 1, 2, 3 and suppose this is minus 2. This point. If you join all these points and you will see that line is passing this way. See, what was the difference? Differences are the coefficients were 1 and 1 for x and y. Here coefficients were 1 and minus 1. Let me explain. Coefficients are changed. So direction of the line is also changed. So what I told, if direction of the line depends on the coefficient of x and y. So before starting the algebraic system, keep in mind the coefficient of x and y are responsible for direction of the line. Now let's see How algebraically it is proved? It is proved. As I told, direction is decided by the coefficients. If we find the ratio of coefficients, like suppose we are finding, check the equation first. This is, I had written x plus y is equal to 5 and x minus y is equal to 5. These two equations. Let's see. If we find the ratio of a1 and a2, that is coefficient of x. See, a1 upon a2, this is 1 upon 1 is equal to 1. And if we find b1 upon b2, this is 1 upon minus 1 is equal to minus 1. Are these two values same? No. And you had seen the graph that the lines were intersecting each other. Means the case arises that if a1 upon a2 is not equal to b1 upon b2, but may be or may not be equal to c1 upon c2. It doesn't matter whether c1 upon c2 is equal to this or not equal to this. It doesn't matter. We have to check the first two ratios, means coefficients of x and coefficients of y. They are not equal. Why? Because the sign of this was changed. Direction is changed. And if two lines are in different directions, in the plane, they will intersect each other, and they intersect each other only in one point. So what is the first case? This is a1 upon a2 is not equal to b1 upon b2, but may be or may not be. It is another case. So the first one, this a1 upon a2 is not equal to b1 upon b2. This case shows us unique solution. And if the two lines are in the same direction and at different distances of the origin, I told the constant is the distance of line from the origin. So if the two lines are in the same direction, it means their coefficients are same. Coefficients of x and y are same. Like I am writing it. See this equation. I am writing 2x plus 2y is equal to, suppose I am writing 6. 2x plus 2y is equal to 6. This distance of line from origin is 5 unit. This distance of line from origin is 6 unit. See, x and y are changed. I am writing this plus sign here, plus sign. So coefficients are just increased by 2 times. This was x and y, 1x and 1y. Here we have 2x and 2y. So it shows that the two lines are proceeding in same direction, but at different distances from the origin. So in that case, if the lines are in the same direction but at different distances from the origin, means the lines are parallel. So what criteria, what condition we will have? Means see, we have a1 upon a2 is equal to 1 upon 2. a1 is 1, a2 is 2. b1 upon b2 is equal to 1 upon 2, and c1 upon c2 is 5 upon 6. 5 upon 6 means we will have parallel lines. In what criteria? Criteria is a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. Means the two lines are parallel to each other, and this happens in case of no solution. This happens in case of no solution. Now one more case I would like to add. Here I am removing this line. See the third case. If the two lines are in same direction and at the same distance of origin, if two lines are in the same direction and at the same distance of origin, let me explain. See, one line was passing this way and this is the distance of line from origin, and another line is passing, or you can say overlapping the same line and the same distances. So what is the case? Means lines are overlapping each other, means both the lines representing a single line. So how it is possible to have two lines in the same direction? Means their coefficients of x and y must be the same. So let me see. See, this is, suppose I am taking x plus y is equal to 5. 2x plus 2y is equal to 10. See, the coefficients of x and y just twice of the coefficient of x, y in first equation. The constant term is also twice. It means both the lines are in the same direction. So what is the ratio? If we have a1 upon a2 is equal to 1 upon 2, b1 upon b2 is equal to 1 upon 2, and c1 upon c2 is equal to 1 upon 2. So what we have the criteria? a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, and this happens in case of many solution. This happens in case of many solution. Many solution means how many types of solutions are there for the two equations? Three solutions: unique solution, no solution, and infinitely many solution. It has been proved with geometry. If we plot the graph of the equations, if the two lines intersect each other, we will have unique solution, because two lines intersect each other at one point only. So that point is unique. So the point is unique, so the solution is unique. Second one is no solution, means there is no interaction between lines, means lines are not touching anywhere to infinite. So lines are parallel, it means the equations will have no solution. And third one is if the two lines overlap each other, or coincidentally the lines are passing in the same direction and at the same distance of the origin, from the origin, the lines represent many solution. It has been shown with the help of graph. Now second one, it has been shown with the help of algebra. How? I told two lines or any line will pass in which direction. This is the decision of the coefficients of x and y, means the coefficients of x and y decide in which direction the line is going to pass. So if we have two equations and the two equations are, if we plot the graph of two equations and the two lines are going in different directions, it means the lines will have unique solution. And how it is possible? Means coefficient of x and y are different, Means if A1 upon A2 is not equal to B1 upon B2, it may be equal to C1 upon C2 or may not be. It doesn't matter. The first two situations, A1 upon A2 is not equal to B1 upon B2. In this case, we have unique solution. Second, for no solution, if the lines are not interacting each other, means lines are going in the same direction, and if the lines are going in same direction, the coefficients are same in two equations. So ratio of their coefficients must be the same. Like A1 upon A2 for this equation is 1 upon 2, B1 upon B2 is 1 upon 2, maybe C1 upon C2 or not, doesn't matter. So A1 upon A2 is equal to B1 upon B2 but not equal to C1 upon C2. In this case we have no solution. And the third one is we have many solution for overlapping lines, and this will happen only when the coefficients of x and y and the constant will have in the same ratio. Like I have written the equation, x plus y is equal to 5, 2x plus 2y is equal to 10. So ratio of A1 upon A2 1 upon 2, ratio of B1 upon B2 1 upon 2, ratio of C1 upon C2 1 upon 2. It means the two lines are in the same direction and at the same distance from the origin. So A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. So the equations will have infinitely many solutions. Alright. Now we shall see the next thing in other lecture. Thank you very much.